Hey everybody. Today we're talking about the empirical rule. The empirical rule, also known as the 68, 95, 99.7 rule, describes the spread of bell-shaped or normal distributions. Here's what it says. When you've got a bell shape, about 68% of values lie within one standard deviation of the mean, about 95% lie within two standard deviations, and about 99.7% of values lie within three standard deviations of the mean. We can also say this in terms of z-scores because the z-score represents how many standard deviations above or below the mean a particular observation is. So for instance, about 68% of values in any data set have a z-score between -1 and +1. Here's an example. The heights of adult women in the United States have an approximately bell shape with a mean of 64.2 inches and a standard deviation of 7.2 inches. So, about 68% of women are between 61.5 and 66.9 inches tall. So what I did is I took the mean of 64.2, I subtracted 2.7 to get 61.5, and I added 2.7 to get 66.9. About 95% of women are between 58.8 and 69.6 inches tall. So I subtracted another 2.7 inches from 61.5 and added another 2.7 to 66.9. Finally, about 99.7% of women in the United States are between 56.1 and 72.3 inches tall, just using exactly the same logic. One more example, and you can pause the video and try this one on your own before seeing my answer. The heights of adult men in the United States have an approximate normal distribution with mean 69.4 inches and standard deviation 3.0 inches. Approximately what percent of men in this population are between 63.4 and 75.4 inches tall? So the key observation here is that those two numbers are two standard deviations below and above the mean, respectively. And so about 95% of the population has to lie between these two values. At the bottom of this screen, you can see the specifics of that calculation.